Hello everyone, today we'll be discussing about the rectilinear motion in calculus normally deals with acceleration and velocity. In this section, we will give two examples about the rectilinear motion problems.
Here is our first example. Suppose a 1 peso coin is dropped from a height of 100 meters. Its height s at time t is s of t is equal to negative 4.9 t squared plus 100. Here is our first example. Suppose a 1 peso coin is dropped from a height of 100 meters. Its height s at time t is s of t is equal to negative 4.9 t squared plus 100, where s is measured in meters and t is measured in seconds. Here are the following questions. First, find the average velocity on the interval 1 and 3. Second, find the instantaneous velocity when t is equal to 2 seconds. Third, how long will it take the object to hit the ground? And the last one, find the velocity of the object when it hits the ground. To find the average velocity on the interval 1 and 3, we use the formula. Average velocity is equal to change of s of t over change of time at the given interval t sub 1. To find the instantaneous velocity when our time is equal to 2 seconds, then we have first to differentiate our given positional function.
Okay, here's our second example. An object falls from rest and s is equal to negative 16t squared, where s feet is the distance of the object from the starting point at t second, and the positive direction is upward. If a stone is dropped from a building 256 feet high, find letter A, the instantaneous velocity of the stone 1 second after it is dropped. Letter B, the instantaneous velocity after the stone 2 seconds after it is dropped. Letter C, how long it takes the stone to reach the ground. Letter D, the instantaneous velocity of the stone when it hits the ground. Okay, here we first find the instantaneous velocity of the stone 1 second after it is dropped. Then given our positional function is equal to negative 16t squared, we have to first find the first derivative of our equation. Then now, finding its first derivative, s of s prime of t is equal to negative 16 times 2, then times t. So, multiplying negative 16 to 2, this will become negative 32t. Then, given time is equal to 1 second after the ball is dropped, then substitute the value of t is equal to 1 second, and then this will become negative 32 times 1 is equal to negative 32 feet per second. So, negative 32 feet per second is our instantaneous velocity of the stone after it is dropped in 1 second. Because we have found out that the instantaneous velocity of the stone in 1 second is negative 32 feet per second, then we have to find the letter B, the instantaneous velocity of the stone in 2 seconds after it is dropped. So, given our positional function, s is equal to negative 16t squared, and time is equal to 2 seconds when the stone is dropped. Then, same in letter A, we have to get the first derivative of our positional function. Then this will become negative 16 times 2, then t. Then multiply negative 16 to 2, this will become negative 32t. Then substitute the value of t to get the instantaneous velocity after 2 seconds. So this will become negative 64 feet per second. Now, we have to solve for letter C, which is how long it takes the stone to reach the ground. So in our problem, we have positional function of the stone s is equal to negative 16 t squared. Then the problem had given 256 feet height of our building. So our function now will become s of t is equal to negative 16t squared plus 256 because this is the height of our building. Then let s of t is equal to 0 in order for us to get the time when the stone reached the ground. So our function now would become 0 is equal to negative 16t squared plus 256. Here, by addition of property of equality, we have to transfer negative 16t squared here. So this will become 16t squared. This will become positive because we have transferred the negative here. Then is equal to 256. Then divide both sides by 16. Then t squared is equal to 16. Then we have to square both sides in order for us to get that time. So square root of 16 is equal to 4. Then we have 4 seconds. Then this is now the time that the stone reached the ground. Because we have find the stone reaching the ground in 4 seconds, now we can solve here for letter D, the instantaneous velocity of the stone when it hits the ground. Now, s of t is equal to negative 16t squared. Then we have the time when the stone hits the ground in 4 seconds. Then first, in order for us to get the instantaneous velocity of the stone when it hits the ground, we have to get the first derivative of our positional function. Then this will become 16 times 2 times t is equal to negative 16 as usual, as we have done last time, negative 16 times 2, so negative 32 t. Then substitute the values of our t here. Then this will become negative 32 times 4 seconds. Then is equal to negative 32 times 4 is negative 128 feet per second. Now, we have found out that negative 128 feet per second is our instantaneous velocity of the stone when it hits the ground.